Rajanandan.
Good evening, Indu.
কেনেকুৱা চলিছে তোমালোকৰ? ঠিক আছে চব?
Yeah, ঠিক আছে, ঠিক আছে. Let's start at 5. Let's wait for some time. একটা ভাষণ দিতে হবে স্টুডেন্টদের একটা প্রোগ্রাম তারপরে আস hello, a very good evening to all of you and a very happy Kati Bihu. Thank you all for joining us live today. Dear juniors, seniors and faculty members, I welcome you all to this lecture series Fantastic Thesis and Where to Find Them, organized by SPIE IIT Guwahati Student Chapter. I am Raj Nandan. I am the president of this chapter, and for those who have joined us for the first time, I shall give a very brief introduction to this chapter. So we are a team of 17 members at present, headed by Professor Taraknath De sir, our faculty advisor, Partho and Akanshu. Today this chapter is here because of the enormous effort and support received from our Department of Physics, IIT Guwahati. I take this opportunity to thank our Department of Physics, our previous faculty advisors, Professor Amarendra Kumar Sharma, Professor Basantaranjan Burwa, Professor Ashwini Kumar Sharma, and Professor Taraknath De, and our previous presidents, Mr. Biswajit, Mr. Gautam, Sumit, and Nagendra, and their teams. So this chapter was basically formed on 30th October 2015. This year we will be completing 5 years, and to make it special, we shall be hosting a number of events this month for school students, UG students, for masters and PhD scholars. The main objective of our chapter is to inspire the students towards science, mainly optics, and to highlight the various scopes and research development and inventions in optics and its relevant areas. We try to achieve them through various chapter activities, workshops, outreach programs, visiting lectures, teaching, International Day of Light celebration, quiz competitions, and many more. So far, we have organized 2 workshops, one in vacuum technology and another one in MATLAB. In optics outreach program, we used to visit colleges or universities and organize a day-long event. So far, we have visited Boroland University, Hoop Kamrup College, Nagaon College, Dibrugarh University, Dhemaji College, Cotton College, and many schools. Many faculty members were also invited by us for the visiting lecture program to our department. But this year, all our conventional previously running program had to undergo a full stop. We had to plan something not we are actually used to. So this year, all our events are virtual. We started with a COVID awareness program. We organized a virtual conference on the International Day of Light jointly with IEEE Photonics Student Chapter. We have organized a virtual quiz event optics for school. Recently, we observed the World Mental Health Day with a motivational lecture series, Breaking Barriers in Science for the school and UG students. For superhero fans, we had a lecture on science behind superheroes. We also had 2 competitions, Let's Write in 3D and Design Brain Map and Win Rewards. We shall announce the winners at the end of today's session. Now, coming back to this event, Fantastic Thesis and Where to Find Them. As the movie says, we shall discover various exciting places and ways to get those fantastic theses. Let me again tell you, this is a non-technical general lecture series for the masters and PhD students of any field. Other interested students are also heartily welcome to this session. This series is planned to show the researchers various out-of-the-box ways to magically improve their planning, illustrations, and representations of the research works for the national, international journals, seminars, webinars, and conferences, and ultimately to reach the point where they can get their fantastic thesis. In this lecture series, we have with us 3 gems produced from IIT Guwahati. Dr. Indu Kalp Dihingia, he is the Masters plus PhD alumni of IIT Guwahati. He recently received the Best Thesis Award in PhD from IIT Guwahati in 2020. He shall mainly talk about his motivation behind the research and how he was able to receive the various awards. Our next speaker, Mr. Samprit Kalita, is a BTech alumnus of IIT Guwahati. He is a coder, artist, graphic designer, quantum physicist, and shall share his various out-of-the-box ways, ideas to give your thesis a look, which is magically fantastic. Our third speaker, Dr. Prakash Das, is again a BTech plus PhD alumni of IIT Guwahati. He was the Institute Silver Medalist and he has received multiple Best Poster Awards, oral presentation awards, 3-minute thesis presentation award, and many more, and share with us his many hidden treasures. So we believe that by the end of this event, fantastic theses and where to find them will surely show us all where we can find those fantastic theses, and we can also be the owner of those fantastic theses. With this, I conclude my presentation, and I now request our HOD Sir, Professor Subradip Ghosh, to kindly say a few words.
Thank you, Rajanandan. It's a wonderfully planned idea. I mean, the idea itself is wonderful. Because when I first saw your mail and with the posters, I was really amazed that our students have, by themselves, have thought about it and planned to arrange such a meeting, which is essentially, mentorship of the other students, and without really any faculty support. A student chapter of any kind is supposed to do these things. Really start thinking their own way, not necessarily always out of the box, but once you start thinking your own way, the out of the box ideas automatically will come. Many a times, I mean, our education system is such that, and the way we are brought up academically is we are very much dependent on the faculty members for every small things, for every instances. We look up to them for advice and, basically for them to lead the way. But this is really a wonderful opportunity. That's why I'm speaking very highly of it. And I really thank SPIE IIT Guwahati chapter for coming up with such an innovative idea. And the list of speakers is really illustrious. I think they have been chosen also very carefully after a lot of thoughts. Indu is the new star in the department after he got the Best Thesis Award in this year. And interestingly, all the three speakers have long associations with IIT Guwahati. Indu was our master's student as well. Sampreet and Joy were our BTech students as well. So from BTechs to BTech Engineering Physics, straight to the PhD, and doing wonderfully well is something to be inspired about. And so I believe that this is really going to be a learning experience for all those who are here. And I could see a lot of names which I do not recognize, which means they are not from the IIT Guwahati Physics Department. So I hope that you will have a real learning experience. And all three are fantastic speakers, by the way. So therefore, there is no chance to be getting bored by an old professor giving sermons. They are of your age and they are full of excitements, and they will, I'm sure, share stories with which you can connect much more than if I speak about them. So without further ado, let me conclude my speech. I wish I could stay throughout the session, but then, there are other commitments. I have to attend them. I wish you all the best. And thanks SPIE for organizing this. Thank you all.
Thank you. Thank you so much, sir, for a nice speech. Your speech always encourages us for good work. So with this, let us now move towards the first talk of the fantastic thesis and where to find them. As I told you before, our first speaker is Dr. Indu Kalp Dihingia. He is currently a postdoctoral researcher at IIT Indore. Dr. Dihingia completed his graduation from DHSK College. Then he joined IIT Guwahati for master's degree. He continued his journey here and completed his PhD, receiving the Best Thesis Award in PhD IIT Guwahati. His research area is astrophysics and more precisely the black hole physics. During his PhD, he has published many works in reputed international and national journals. His work is also acknowledged in multi notices of Royal Astronomical Society, Oxford Academy. He was also a member of SPIE IIT Guwahati student chapter. We are so happy to have him with us today. And without further delay, let us all move directly towards him. Thank you. Over to you, Indu.
Yes, just a minute. I am trying to. Okay. Yeah. Oh, but one problem appeared actually just around my room because these people are cutting grass, so it's making lots of noise. Probably you are also hearing lots of noise from my speaker, right? Am I audible? Actually,
Yes, you are audible.
Okay, there is no noise.
Yes.
Or...
Yes.
Okay, so let's start. Okay. Hi, I am Indu. So, one day Rajnandan called me and he asked me to actually speak about my journey of my PhD life. So, definitely, I asked him for how much time I should speak. He said as you wish. In reality, for the if I want to speak about my PhD life, I can speak years or probably like that. But today, don't worry. Actually, I will not take much time. Probably I will take 30 minutes or so. I will basically speak some of the things that I learned, I experienced in my PhD life, and in general about the research. So I think I should give a disclaimer before going to the further slides. So basically, this talk is completely based on my experience of my PhD life. So it may be conflicting, some ideas maybe and thoughts may be conflicting to someone else. So I have my apology for it. And the images that you will be seeing in the slides, those are taken from many online free sources, and some are taken from some websites. So I have not actually cited them in the proper places just to make it a little bit better actually, right? So, but I have gratitude for all the sources. So, when I was in class 9, actually, I got a chance to read the book A Brief History of Time by Stephen Hawking, a Assamese translation version. Actually, its name was Homoyor Ek Sankipto Itihak. So, in that book, actually, Hawking narrated a sentence like scientists and prostitutes get paid for doing what they enjoy. That I definitely. Not sure about the prostitutes, but I agree 100% that scientists enjoy what they do. And this book actually left as hours for science inside my heart, somewhere deep inside. So I always acknowledge this book, that from this book onward, I started actually questioning about the surroundings, how things are going on, how universe is going on, and all those things. So from these books onward, I started my research journey, or my logical thinking, or that journey started from this book onward. So let's start with some philosophy kind of stuff. Do you really need motivation to do research? Basically, that is the question, right? But our surroundings is full of motivation, and everyone has their curiosity and limitations. So basically, in my opinion, everyone does research. So I will actually brief some examples. Like the first example, you can see my cursor is the left side, the figure here. Actually, here this is the model of universe. Actually, it was drawn by Copernicus. So at that time, for him the universe means the solar system basically. So at that time was a very difficult time. Basically, the Galileo when he supported this Copernican model, basically he was sent to lifetime imprisonment and he died there. So in that time they actually started thinking, and they actually published this model of universe. But interestingly, you can see he left many places outside, and some star symbol and some symbol outside. Basically, he wanted some free space for the gods, because that time going against the god, going against the stars was like going for death. So that was his. That's how he actually kept the SARS happy at that time. Okay. Secondly, you can see there's a bulb in my presentation. This bulb is like a symbol of our scientific discovery or scientific excellency, because excellence. So actually, when we were kids, at least me actually, I used to think like how this bulb is glowing. Like it has a filament which is glowing, and like that. When you turn up the switch, just before few days, one like BSc student or someone, he asked me this question like, how it happened that if you just switched on the light and bulb glow automatically? I of course answered him like from this like basic physics point of view. But thing is that that's the curiosity you always see from the bulb itself. We get our curiosity that how it is happening. And interestingly, Edison, who invented this bulb, actually, he had to discover tens of elements to find the suitable elements to make the filament so that it glow nicely and it do not burn out with the electricity. So that's a symbol of our scientific excellence. And this man you can see over here, he is a like Padma Shri awardee. His name is Uddhav Bharali. He is a great inventor he is from Assam itself, North Lakhimpur district. He invented many machineries for the differently able peoples, like someone who do not have legs. He made some robotic legs for them, and for people who are like handicapped with their hands, so he made some instruments so that they can ride, they can eat their foods and like that. So his inventions are mostly related to the common people who are like rural people. He developed those kind of things. So that's why he is praised internationally and nationally. And this you can see there is a boy actually who is doing something. This is from the movie trailer, the boy who harnessed the wind. From there I have collected it. So basically this movie is in Netflix. If you have Netflix account, please go and watch it. It's a beautiful movie. It's actually based on the life of William Kamkumba. This Kamkumba, I don't know whether I am pronouncing it correctly or not, but this movie is very, very beautiful actually. What happened in Mozambique actually, there is a situation of like flood and drought and those things are going on. So that time he was a kid, like 12-year kid or so. The little expertise, little science he came to know, he used it. Basically, according to him, he saw an image of a windmill actually. And from that he figured it out that how to make a pump from the wind in their village. And finally, he successfully managed to build such a harness wind power to run a water pump to actually for his village. And lastly, you can see there is a farmer who is plowing his field. This is also I find is very interesting because the way he is doing it fascinates me. So basically, my idea is that everyone around us, all the farmers, everyone doing some kind of thinking inside their head and doing some innovation. Every day they are doing it. So research is not new to us. We did it from our childhood and we are doing it. But in reality, PhD is not just research. You have to do many things other than research. Like you have to go to a horrible course, or horrible is probably not a very good word to say, but it's very, very difficult or different what to say. And you have to go to a comprehensive exam, progress seminars, TA duties, and conference duties, and all these things will be coming to your your life again and again. So in that kind of situation, in PhD, in reality, you need motivation. You need lots of motivation. And it's better to find a source which can give you a constant motivation. So like some people find a hot cup of motivation from a hot cup of tea. And of course with adrak, ilaichi and everything, and some find in green tea. So I prefer green tea. And samosa, pakora, everything. It's in IIT Guwahati, especially these things are readily available. You can find around the corner actually. But it's in reality PhD level still very stressful. So some people go to some the sill beer or something to find some relief. And people develop many hobbies in the PhD life, like plantation, cooking food, and then some people go to the music itself, music also. So they find new hobbies to actually handle all kind of situations, and I think this is a good practice also. And nowadays Netflix and like Amazon Prime videos and Disney Plus Hotstar, they are also helping research scholars, I think, in a very good way to handle the stress levels. So the first step, I think, for a researcher to forget everything you know. Basically, I will actually tell you the story of the electron in the hydrogen atom. What happened to the electron? Basically, when it is excited or when it is in ground state, it can absorb energy and go to excited state, right? And when it comes down to ground state or some lower energy level, then it radiates. So basically, if you want to radiate, then you have to come to ground state. Or if you want to absorb, then also you have to be in ground state. So basically, ground state is much more necessary. And if you want to absorb knowledge and you want to start the PhD journey, first thing is that forget everything you know, just come to the ground state. Then, yeah, and if you have already started your PhD journey, I am like more or less sure that you have started it from ground state. The idea is absorb, radiate, absorb, radiate. That is the process. You earn the knowledge, write a paper, publish it. That's all. Again, come to the ground, again learn it, publish it. That's the process, right? So, yeah, so first point is that forget everything you know. And
Indu?
Yeah.
Yes, sorry to interrupt. Actually, can you click hide on the line that is coming on the bottom of the screen?
Yeah, yes. Sure.
Yeah, that's fine. Okay, thank you.
Yeah, okay. Yeah, thank you. So, yeah, next. And in PhD, in reality, you need lots of patience. Mostly not to do research. Like when you will be writing your paper or something or thesis, then you have to, when you are making a figure, you have to change the color several times. Like for the first half or whole the day, we will be changing colors of the same figure, and you will be looking at it, you will be not satisfied, and you will go to your supervisor. He will be not satisfied. He will say, no, change it like that, and things will go like that. And you will try, if you are plotting some curve, then you will try many different line styles, and whole the one day will go like that. You will changing the line style and kind of that. Sometimes you will be like increasing your figure size, decreasing figure size. That's how time goes actually in reality. And if you are doing in experimental labs like cleaning, probably while cleaning you will break up few things, and yeah, of course you need to bake your sample in oven. That's why I use the term baking. And in the coding you have to dig the error where you have the compilation error and everything, and most of your time will go like executing such kind of command like ./a.out or something similar, depending on whatever you are using. So like that's how it goes. Like once one of our HOD from our department, he said, like anyone from Aminggaon, if you bring someone from Aminggaon, he can also do these things. Aminggaon is like the nearest place by IIT Guwahati. So, and he is correct also. Like if you want to only do these things, then anyone can do it, right? But yeah, of course, I want to mention one thing also. This flop show, basically Jaspal Bhatti show, he actually portrayed the life of PhD scholar in one of his episodes, like episode 5. But the kind of the way they presented it, I don't know. At least in IIT, that never happened, or it not happened, I think. But still, you can have a look. It's a nice video. Actually, it's a 25-minute video. It is in YouTube, so you can watch it freely. So it's very, very interesting. But apart from all this thing, we do something else. We also do something else. It's amazing, actually. Due to our collective innovation, like the 250 tons of Airbus, it's take off, fly, navigate in the sky, and successfully land on the ground. And like it's like you can if you look at carefully, actually there are many things that are involved. Like the Bernoulli principle is involved, the jet engine is involved, and the radio communication is involved. Everything, it's like if you think it if you break it in piece by piece, then you will see somewhere, sometimes some researcher, some engineer, maybe he may not be like a PhD scholar, but they were like working, building piece by piece to lift the flight to the air. And now, like we have a very good communication system, like by air. So, secondly, we know like a lot more things nowadays. We know that black hole exists in the universe. That become possible because of the excellent theorists and the intuitions by the many intuitions of theorists, and then the engineers who actually who build those radio telescopes, and then of course the supercomputers. For that, actually they can combine many radio telescope around the world to build a effectively art size radio telescope, from which they actually they collected the data from all over the world and combined to make this EST reconstruction image. And that image is basically exactly, you can see it's look like the simulated image in the left hand side. So from that, actually here also you can see how our like collective research areas, research scholars, they contributed to get this kind of knowledge to us. Just before few days, like NASA published one article that like now we have room temperature superconductors. Here also in superconductor is basically, you can see it's like a pure core theory and core experimentalists, they came together and they actually they build this one. So here also you can, if you look it carefully, then you will find the contribution of research and research scholar everywhere. Yeah, and here also this before like 1 year or so, one of our Indian group also like claimed similar things. Actually, that is also a good. I think it was also a good contribution to this room temperature superconductor. But good thing is that this room temperature superconductor has like the incredible amount of applications. It can like within a decade or so, if it comes to the market, then it will change the all the phases of the technologies in reality. Let's let's see actually what new things come. And apart from innovation and research, the PhD offer us a good scientific temper within ourselves, so you cannot be potentially like or easily misled by anyone. So nowadays the internet is like full of information, and of course fake news and knowledge, everything is there. From that, if you want to collect the proper information that you need, for that you need a scientific temper. It may not be required to be like related to science or anything, but it's just temper inside our brain. So and you know what is going on around you, like what are the physics or what are the science going on around you, the new technologies, or what is going inside your health. Like if you are having some fever or something or anything, you can relate it to something else actually, and you question everything around yourself, around you, and just logically. You just don't you just judge someone loosely or something loosely. You just think about it and then you judge it, and finally you live well, hopefully, actually. So basically, when you finish the PhD, probably you will have a rock solid personality. That is my belief. And research is actually very, very beautiful. Like here, I will show you one video. Basically, that is the collision between clusters of galaxies. Believe me, I don't know much detail of these videos, but if you want to actually more information about this video, you can go to National Radio Astronomy Observatory website, and here also in the video they will put some of the reference. You can go and find the detail, but I am just putting it to show that how beautiful the research can be. Here actually they combine the result from the observation and the simulation, and then they created this video. Let's watch this video. Here you can see these clusters are there like colliding, and software is going around. And this software basically heats up the galaxy, the gases in the intergalactic space. that was, I think that was the video. Hopefully you enjoyed it. Yeah, next, I would like to speak a few things about my current work. So this figure, you can see actually what happened from the black hole. Actually, people observed that some relativistic jet kind of relativistic particle actually they are ejected from the black hole polar region. So in here, actually, I am trying to understand actually how these things come out from the very near to the black hole and with such a high speed. So here I am doing some general relativistic magnetodynamics simulations here. So basically in the figure you can see there's the purple color and the bright color is in the polar region. That is basically the relativistic Z. And this in here actually you can see there's this kind of structure that is formed. Actually that is the gas. That is when a black hole attract gas. It's actually due to its angular movement. It rotate around the black hole and form a disc kind of shape. So in astrophysics, it is called accretion disks. Actually, in the accretion disks, the magnetic field lines they actually curl around and they drive some of the matter in the accretion disks with a very relativistic speed around the polar region. And interestingly, the way they actually get this energy, it's known as a Blandford-Jeniak process, and which is like generalized version of the Penrose process. Now I will not go to detail of these processes, but one thing interesting thing is that this particle or the relativistic jet get energy from the black hole's rotation and energy. So that is one of the interesting aspects actually we are looking at in my current work. But thing is that we are doing some kind of very big mathematics, we are running some codes which takes like GB, like hundreds of GBs of data are created. Like why we are doing this basically, right? So in reality, we see this kind of jets everywhere. Basically, when people see the universe with radio telescope, they find that this in the left side you can see this is it's known as protostellar jet. It's basically coming from the star, which is the newly born star, and around it the planets are forming. In that kind of situation, the star can actually give some kind of jet kind of structure. This is image from HS212 source, and then this is the extragalactic jets. Here, Cygnus A, it's a galaxy actually. At the center of the galaxy, there is some black hole or something is there. From there, actually, a relativistic jet is coming out. So, and then they have zoomed it and they zoom it further actually. So we can see astrophysical jets from the center of the galaxy as well. And this is the right hand side is this from the microquasar. Microquasars are basically a low mass black hole, like its mass is 14 solar mass, and from there also we see that that kind of structure. And when we are from our telescope in the sky, we are looking these kind of things, and we are trying to actually get the ideas how these things are happening from our understanding of gravity and fluid dynamics together. So yeah, and now I would like to tell this about the Nobel Prize 2020. Actually, Sir Rosa Penrose, Professor Reinhard Genzel, and Professor Andrea Ghez, they are awarded with Nobel Prize in 2020 for discovery of supermassive black hole at the center of the galaxy. Basically, the general relativity always predicted that there's some kind of singularity is there, but people were like thinking whether that is a reality or that is it's not a physical thing. That many people tried to remove that singularity also, but Rosa Penrose, Hawking, they come up with an idea that no, this is a reality and it must exist in the universe. So they said that they say that this singularity is covered by this event horizon surface. There is a surface around the black hole that is an imaginary surface that actually always surrounds the singularity so that you can't see it. So that kind of, they claim that kind of things. And then finally that they actually claim all this thing is 1960s, and in 1990s this Professor Reinhard Gengel and Professor Andrea Ghez, they actually did some very good observations of our center of our own galaxy, Milky Way. They basically traced the trajectory of the stars at the center of the galaxies, and they found that all the stars around the center, they follow a common point. There's a star at the center. You can see that they did this observation differently, actually, not together. So they found that if they actually put something at the middle, some mass, which is like around 4 million solar mass or so, then with their known mathematics, they can explain all the trajectories of those stars. Then that's why they claim that there has to be a 4 million solar mass kind of object, which is very compact at the center of our own galaxy, Milky Way. And that kind of compact and heavy object can be only black hole. So they claim that it has to be a supermassive black hole. And they claim that in all the galaxies, this kind of supermassive black hole exists. So finally, the way I have shown an image of this, some black hole, the images of the black holes actually, basically that is known as black hole ring, EST ring or black hole rings. So from that, actually, they confirm it more profoundly. That's why this year, actually, Nobel Committee decided to give Nobel Prize to these two gentlemen, one gentlewoman or lady, basically. So now there always one question haunts us, the theoretical physicists, like, why theoretical physics? Like, is it a waste of time and money? Of course, like, the experimental physicists or the technology based, that's very important. Without that, nothing is possible. But is it really that the theoretical physics, the we do, it's worthy? So in this slide, I will try to explain some of the facts. Basically, in electricity and magnetism, they were thought to be completely unrelated forces, like the kind of experiment Faraday did. From that, it was like they were like two different forces. So, but Maxwell unified it theoretically, and from that unification, now we have electric motors, generators, safe electricity power distribution, the power grid, basically radio, television, smartphone, and wireless internet. Everything is coming from the same the basic concept, the unification of electricity and magnetism, basically electromagnetism. So, and interestingly, the CERN, basically, you know that is in Switzerland. Actually, they are searching. They were responsible for the discovery of Higgs boson. So in CERN, actually, the first proposal of World Wide Web, basically internet, was written by Berners-Lee in 1989. And today morning, I went for some vegetables and I paid like 33 rupees to a vegetable vendor with Paytm. So you can see how from the research level, things are coming to the grassroots level and affecting all of us. And like the fourth point is that Einstein, he discovered that matter is like concentrated from energy. And from that, actually, now we understand how sun works from the process of fusion. And from that understanding, people build nuclear reactors and nuclear weapons. And now people are looking for the nuclear reactors for this energy crisis that the world is currently going through. And of course, the Einstein understanding of gravity provide a roadmap to build global positioning system, or known as GPS system. And the use of this GPS in technology is very, very profound. In like in normal our day-to-day navigations and in military and everywhere. So here I have not included. There are many more. Actually, I have not included all of them. But this is for sure that the fundamental physics always drive new innovations in science and technologies. So one of the questions I was asked to address, like how and why I got best thesis award. Frankly, I don't know. Mostly because IITG started it from this year, that's why probably I got it. But I can say actually how I wrote my thesis, and I think this is a very common practice to write in this way. So first, I started with a relevant introduction at the beginning. So do not write too much in the introduction. Just give a brief or maybe all the relevant things that you are going to say in the later chapters, and make a complete story in the introduction. Explain all the mathematical background and experimental setup thoroughly. Divide the chapter based on the completeness. Finally, combine all the chapters to make a full course menu, and write a brief summary and futuristic plans, works possible from the thesis. From that actually futuristic plans and works, from there only a reader can understand the worth of your work, what you can do later from your thesis. Yeah, of course, follow your guide. So go and enjoy conferences. I have in my PhD, like I have traveled all these places like Mumbai for a conference and visited nearby places, Indore also, yeah, Kolkata also. For I Nainital, Tezpur, Tiruvananthapuram, Pune. These places like Bajirao's palace was there, so we went to visit there and go to the conference and enjoy the conference and roam around, and then you will definitely enjoy it. Yeah, and enjoy a lot with your friends. Like do parties, go for dinner, and do madness and travel nearby places where you are staying currently, and that's how you can actually enjoy your PhD life. And yeah, at the end, thanks. And in summary, all the best to everyone. Yeah, over to you, Raghunandan.
Thank you so much, Induda. It was such a nice talk, so motivating, and it will really help us a lot now to plan our work also and to keep us inspiring. So I would like to now open the question answer session. So if
Okay.
anyone have any question, please ask.
Yeah, you can write in the in the message also. I can read and answer it. Actually.
Yeah, if you want to ask directly, then you can also ask directly.
I think there is none. Sir, you have told your current work. This is launching of relativistic jet from black hole. And please don't call me sir. Okay. So I have heard that even light cannot escape from it. Then how? Yeah, exactly. That is the question. If light cannot escape from the black hole, but still you see those relativistic jet in your observation. So how these things are happening? So for if you want to understand it, then you can actually when a black hole is rotating, actually they form a region known as ergosphere around it. So in the ergosphere, what happened if a particle actually what happened if a particle actually they disintegrate into two, like one is with negative energy, one is with positive energy. So this positive, that one particle actually it guided by the magnetic field and leave the system, and another particle go to the to inside the event horizon. That is the basic principle of the Penrose process. So from that actually you can the particle actually moves leave the system with relativistic speed. So yeah, that is the basic thing actually. Just how far we have come to understand singularity. The singularity, like that, I am not sure. But thing is that my workplace is outside the event horizon. I know things what are going outside the event horizon, but inside the event horizon, the singularity is staying inside the event horizon. So I don't know much about that, like current scenario of the how much we know about the singularity. How to choose PhD topic and guide. Okay, so yeah, how to choose PhD. So basically, you choose a topic that you like most and try to get faculty of that your same field. That would be great if you get it. So it's a very difficult question to answer. Basically, write to the faculties whom you want to work. If they agree, then go and work with them. Actually, okay. Can you explain about the standard candles? Okay, yeah. So I don't know much about this subject. Basically, I am a theorist. So standard candles are those things people use actually in their observation to compare their luminosities and this and that's how that much I know. But for me, actually explaining it completely will be difficult. Okay, then one question: how do we choose the guidance topic? Okay, that I have already said. Often choice are limited for most of us, and we are forced to choose topics. Yeah, that's why actually one of my slide I said come to the ground level. Actually, forget everything what you love and what you like, and then because sometimes you may not actually get the thing that you want to do. Is there any common portal where we can know about ongoing workshop and seminar? Yes, there is. Like you can. There are. If you type in Google, then I forgot the website actually. There you will find all this information actually. The kind of conferences they are going on around the world and India. So there are that kind of space actually. If you need, I can share with later on. You can write me a mail. I will give you. I will write. Yeah.
Indura, this is Angana.
Yeah.
I have a question. So, you planted orchids, you fed us a lot of good food, you cooked as well,
Yeah.
and then you got the best thesis award also. So, during your PhD life, did you arrange your whole day in some sort of a timetable so that you could do all of these things together?
Not really, actually. But thing is that those things like planting orchids and cooking, those were like I do all these things so that I can get relief from my stress and like that. So mostly I cook new things when I am mostly stressed. Okay, then I like forget everything, all what happened to my daily life. And orchids, like you probably people have seen me actually in between and the last time I come to the currently where the orchids are there for 10-20 minutes, I look at them and see them and then go back and like work again. So that's how. And mostly I always work in the daytime only, like morning from 9 to like 12, then 2 to kind of 5, 6. That's what that was my working schedule actually. Apart from that, I didn't go to lab much, but the brain is always like it keep on actually thinking all these things all the time. That probably I don't work like that way, but brain always works actually, in mostly like 20 hours or so, or less than the 18 hours or so actually. Yeah, there were some more questions, I guess. Yeah, I hope I answered you, Angana. So,
Yes, you answered me.
I have one more question.
okay.
So,
Yeah.
what was your first reaction when you heard that you have got the thesis award?
My reaction was how I got it. I definitely they chose me not because of my writing skill, definitely from my work actually that I did there. I thought like that. Possibly, because writing skill wise, I am not very good. But what I did, probably they liked it actually. The committee, they actually suits in the department. I had prepared my master thesis, but felt difficult to write in my own words. Yeah, so yes, okay, yes, if you are having problem in writing in your own words, then you can actually translate whatever you are copying some from somewhere, right? That is the problem. So while you are copying, you copy in your own language, mother tongue, either Hindi or whatever language, then translate it again without looking at the original from the original place. Then probably definitely you will write your own words. Yeah.
So I would like to make an announcement. So we shall have a discussion session at the end of the event also. So if you have any more queries, you can again ask there. So can we move to the next speaker then?
Yeah, I think so.
Thank you, Indu, again.
Thanks a lot.
So our next speaker is, as I mentioned, Mr. Samprit Kalita. So he is a BTech alumnus of IIT Guwahati. Currently, he is a research scholar in our Department of Physics. The journey is so attractive, and he has experience in multiple fields. He was a software developer in the intern, as software developer intern in R&D Rupik Fintech Private Limited, in AAA department and CSA department of IIT Guwahati, Tezpur University, and many more. And he was a junior research fellow at Computer Science department as well in Tezpur University. And he had done a multiple number of projects. Like he had developed 17 applications, 12 graphic design 12 graphic designs, 6 product design, 3 IoT devices. And you can see this is the basically the graph, like how he is progressing. Each year he developed more than 2 to 3 uh, projects. So simply, if we need to say, he is basically a coder, gamer, writer, dreamer, musician, art lover, physicist, researcher, and he basically works in the quantum technology. And you can see this one is basically drawn by him. This is the digital art he made, and this is also made by him. So it will definitely help us a lot. So he will share how we can also incorporate the out of the box ways to magically improve our work. So complete that. Can you hear me?
Yeah. So, am I audible?
Yeah. Good. Over to you.
Okay. First, thank you very much, Rajan, for making me part of this wonderful concept, fantastic thesis, and way to find them. And a very good afternoon to everyone. Indeed, we all know how important it is, like, to connect a reviewer, reader, or an audience to something like a thesis, which may have become a very important part of our academic journey, or a poster depicting our hard work or a presentation of our results. And as Induda already pointed out, it takes several iterations to perfect the elements that constitute these two. So through this informal talk, I'd like to give a visual demonstration of tools and ideas from the design perspective. And even though these things are not core to the work, they might help you enhance the aesthetic of the work that you present. And I'll also try to cover some conventional techniques that can help you boost your productivity and keep you motivated over the course of the study. So I'm going to share my slides now. Okay, please let me know if they're visible.
Yeah, it's visible, Sabida.
Slides are there, right? Okay. So before jumping into the content of the talk, I'd first like to point out some of the key takeaways from this presentation. Metaphorically speaking, charms or spells here represent the ideas that help us tackle some circumstances which we come across, and based on our instincts and habits. And to successfully implement these ideas, we need to rely on several tools or resources, metaphorically potions. Moreover, to maintain productivity over a period of the pursuance, we need to stay fresh, right? So, which is where the co-curricular activities come in. So, I've tried to cover some of these ideas, tools, and activities which can help you utilize and showcase the work with some examples through visual illustrations and videos. And here, benchmarks. So to give you some more context, I'll be sharing a little bit about my journey till date, and then I will dive into the main content of the talk, that is creating and composing visual elements, maintaining and planning your progress, handling situations, and improving the odds of your success. Learning new things in between to build up your confidence. And finally, I'll be concluding with pursuing co-curricular activities. I generally use the Nick quantized when it comes to online content like blogging or streaming, and even for some specific projects. But in the non-virtual world, I am a graduate in engineering physics, as Rajnan has already mentioned, and have completed my bachelor's in music too, that in instrumental violin. I also had a taste of the software industry while working at Repeat, and there I got the pre-placement offer, but because of some priorities, I decided to stay in Tejpur, which is my hometown, and there I temporarily joined CSE department of Tejpur University. I carried out several projects there and founded a startup called Secure. Then finally, to quench my thirst for quantum physics, I joined a doctoral program in IIT Guwahati, where I currently am pursuing PhD. And I also co-founded Fastboard AI with two of my good friends, and we are currently working on this open source libraries for machine learning tasks. And throughout, I have gathered interest as well as worked on diverse projects, and I hope to share some of the resources that helped me shape my journey this way. Now, primarily, my tasks that I worked on involve cryptography, which is used to secure quantum information, which is classical information basically, and then machine learning and its applications for the Internet of Things, or the IoT, and recently, quantum optomechanics, where light interacts with atoms in the quantum regime. I have also completed a few mobile and web applications over the past years, and recently worked on a mobile platform for online selling of goods during the pandemic times. Additionally, I have attended some music conference and workshops, as well as been performing classical music ever since my school days. With that done, let's dive into the main content. Now, one of the major impression givers of your hard work is the aesthetics of how you present your results, right? So be it your thesis or just term paper, or maybe a presentation or a poster, the more relaxing it is to the eye of the viewer, the more interested he will find or she will find while viewing it. So well-crafted content and some nice-looking structures boost the visibility and the importance of your work. You can also appropriately direct the focus to the particular elements through the illustrations and schematics. Here, I will be discussing some tools and resources that you can use to make your illustrations, plots, and flowcharts fantastic. Most of the theorists need to display a diagram, right, of the theoretical model, or the experimentalists need some schematic of their experimental setup. So sometimes you need both. And most people usually used to do this in Microsoft Paint. Yep. It appears like people have performed feats in Paint too, such as this one by Patrick Hines. This is a Godric's Hollow from Harry Potter. And I was so inspired by this artwork once that I literally sat down with my Paint tablet to, make something paintastic. And after an hour of painful struggle, the closest I could go to replicate this image was this. Okay, close enough. Anyway, due to the absence of hotkeys and shortcuts, a lot of time is spent clicking on the interface and just adjusting the parameters of the objects in Paint, right? So there are also no ways to segregate the elements into individual layers, which is why it's difficult to modify a particular section of the diagram at a later point of time. So a better way to make diagrams is to use free raster graphics software like Krita, Sketchbook, GIMP, or vector graphic softwares like Inkscape. So due to a lot of advantages of these, and they have some intuitive features which make it easier to illustrate two-dimensional models and properly label them also. Like without even getting a pen tablet, you can make very visible models. So here is an example of a simple technical illustration done using Krita with mouse, which depicts an optomechanical cavity driven by a laser drive, which is in blue, and the cavity field is in red. So this is the area I'm currently working on, optomechanics. So another requirement here in the papers or the reports, it's the flowcharts, right? So for flowcharts, we can have offline tools like Pencil, and online platforms are also present like draw.io or lucidchart.com. Like here's an example of a draw.io flowchart. But for most of the cases, you might already be familiar with Microsoft Office, PowerPoint, and Visio. They serve the purpose of making posters very well, and also for vector-based illustrations. So if you own a copy of Microsoft Suite or have an institute subscription, give it a shot. On the premium end, there are Photoshop, Illustrator, or the mobile-friendly versions of those, Sketch and Draw, which are available on the Play Store. And if you're lucky enough and have an iPad, Apple's Procreate is a go-to application for illustrations. Now, a 2D illustration is usually sufficient to represent your work. However, if you want to make the viewer visualize it further intuitively, you can make, and also if you have some time at hand, you can go for 3D diagrams where you can add a couple more features like lighting, shadows, reflections and refractions, a little bit of roughness here, a little bit of textures there, and that's it. So basically, with a similar idea of mine, I jumped back to using Blender for a crude recreation of the previous optomechanical setup I showed, this time in 3D, and here's the result. So you can see it looks pretty intuitive in 3D, right? And similar tool for 3D modeling is SketchUp, which provides an online interface for free and a downloadable offline version for subscription. And there is software like Rhinoceros 3D. So I remember using this in my childhood when we were constructing our first floor, and I built the 3D model of the house using Rhino 3D. And additionally, I explored some other software also, like ZBrush Pro is another one. And some of you might already be familiar with SolidWorks, right? For 2D modeling and 3D modeling, and AutoCAD, especially like in the mechanical engineering field, we have SolidWorks and AutoCAD quite popular. And there's Maya, 3ds Max Studio, etc. That very good job in that. So, but most of the cases, Blender and SketchUp should suffice the requirement unless you need to work on some specific modeling simulation software. Well, now that you have all these tools at hand, you can start with your illustrations, right? Not yet. There are a couple of things that require attention a bit more. Like there is selecting of colors. So very bright or too dark colors can strain the eye and generate all sorts of emotions that are except from the one that you have desired for. Like you should be careful in choosing them. And a good way to know which colors go with which ones is by spinning this Amazon Wheel of Fortune, also known as the color wheel. And now there are also schemes to which color to choose with which one and which goes with which one more. And most of you might be aware of them already from your preliminary education. And for this particular presentation, I have used the split complementary color palette, a scheme where two colors are equidistant from the third one, but closer to the one another. And to learn more about how colors or these palettes work and toggle them yourself, you can visit Adobe or Canva, which have more extensive resources. The other important thing here is composition, which is primarily related to the relative relationships of the elements of the illustrations. Like suppose we have a background such as this triangle here, and now we try to focus something which is on the foreground. We would opt for a darker color scheme, and there will be a sweet spot of contrast where it does not strain the eye. And these things you have to take care while making posters also. And finally, we have to make the viewer focus his eyes on the way we want to track it. And for that, we need to position the elements right, and then we need to resize the elements such that they look properly balanced. And that's it. So like if you want to follow some more concepts and free tutorials on these things, like there's always online resources. Like I found these two very useful, controlpaint.com by Matt Corr and Blender Guru by Andrew Price. They have awesome content. Now, illustrations are just a small part of the larger scenario which represent your research work or whatever you have been doing pursuing, and completing that is itself a journey involving bits and pieces of regular activity. But often we get so caught up in the hustle of what we have to achieve that we barely get time to wonder that there are better ways, that some things can be done. And most of the times, we get so high spirited and enthusiastic to organize our fast paced lives that there's always a deadline approaching and an examination knocking at the doorstep, right? So here comes the need of some resources that help us worry less and focus more on getting the best of our time. Let me take a simple example here. Let's say I start with a report on some topic in LaTeX. So I start with a blank text file and I fill in some title and sections and add on some observations with each day. But as I go on adding more and more content, the file becomes longer and longer and difficult to debug, right? So I create different text files for individual sections and include them in the main text file and hit the save and just call it a day. And next day, I open the files and it appears I have moved the same section into two different section files, and one of the sections that I took a day to write probably is missing. Now with a sad heart, I can start again with the work and keep track of the progress by zipping the contents of the day and storing them in a backup folder, conventionally naming them and with the proper versioning. And then one morning I feel like looking at the section which I modified about a week earlier and find this. Okay, so I have no idea where the file is, the one that I require, and since I did not keep a track of the change log of the versions, I don't even know where to check. Or the best way now, since the deadline is approaching, is to let go of this and continue with the current version and edit that. So to avoid all this fuss, we can track changes using version control systems. Most common among them are like Git and Mercurial, which store instantaneous snapshots and differences between consecutive versions. Moreover, they provide other features also and scalability over multi-user projects. So with a version control system at my disposal and a proper changelog of the versions, I can travel back to the past editions quite easily without getting overlapped. So a same situation might arise for references, and saving each and every reference as a big text file and the one that you found useful probably. So that is quite a hectic task. So one can rely on standalone and add-on tools like Mendeley and Chotero. These are pretty good. And even after all of these things, the electronic components of the computer might fail, and that too also without warning for a number of causes, which is why periodic backups are very important. Now, organizing these things is almost a friendlier task. It's less hazardous or less time consuming than organizing your time itself, which is a whole different story. You first try to accomplish something in an estimated amount of time, and then somehow something else comes up midway, which you obviously can't ignore, and then one thing leads to another, and then you're close to the target time without the work getting done at all. Or even if nothing happens, you lose interest midway or get distracted, right? This typically happens due to the lack of focus. To improve this, the Pomodoro technique can be followed, which it basically has intervals of focus followed by short breaks to retain productivity and freshness. Websites such as Pomodoro Focus and mobile applications that Focus to do provide a minimalistic framework to time your work in such a fashion. Plus, one can also plan and assign the time by to-do applications, and some of the ones that I have been using are my Study Life and Microsoft To Do. But the most important thing here is to form a good habit of completing them. So if you have just begun planning, pick smaller tasks for shorter durations and be regular with those. And once you have gained the consistency, you will be able to increase the difficulty level gradually to a point. Okay, so but what if there are a lot of things around us? How does one decide which ones to pick first? that's where this section comes in. I'm mentioning problems here, but this should be applicable to most tasks that come to us. So we are constantly bombarded with something or other throughout the day, right? So some of them might be personal problems popping up from time to time, making us inconsistent or draining our energy. Some of others may be related to the current work we pursue, which decrease our productivity and make us anxious. A few others might be rising from the current situation or the environment that we live in. The situations differ from individual to individual, and we can start identifying the primary problems that bothering personally every individual by noting them down or making a mental sketch of everything. And once we have that, to make things clearer, we can group them in terms of their priority or the type of problems. So once visually we have separated the problems, it becomes a little bit easier to assess which problems need how much attention and what time each of them will take to resolve. So you can ideate ways to resolve them, and following a proper planning of how and when you're going to tackle these, all the pop-ups can be taken care of, right? So usually tackling is less time consuming. No, it's more time consuming actually. So yeah, so this is how you finally move toward the final step of implementing the plan. Even with a well chalked outline, execution of the planning is still a tough thing, right? So, but with if you do it dedicatedly and cultivate regularity and be honest with one's time frame, one can find the right way of achieving a balance and retain the enthusiasm to complete the tasks at hand. Let's take a simple example. One of the common problems that is faced by a lot of students is with programming skills. Be it a simple task like generating some random numbers or a bit complicated ones like writing simulation software. At some point of time, people in both experimental and theoretical research have to acquaint themselves to some kind of a computer language, right? So in my case, I have encountered two types of motivations behind learning a language. The first type is learning in depth, knowing the common functionality of the language as well as some advanced topics, so that one can see it for placement rounds or interviews, or maybe just for some personal quest. The second type is about gathering the minimum knowledge required to complete some different problem that requires the language. Let's break down each of them. For the first case, we need to identify the topic of importance or the corresponding interests. This can be done by reading a book or a relevant course if you have time, or if you are tight on time, then you can get to understand the essential concepts by practicing alongside learning. If you go a couple of algorithms a day, that's a good speed. There are some of very extensively illustrated online resources. Like in Geeks for Geeks and Tutorials points, you'll be finding some proper learning methodologies as well as how to proceed for each step of the programming. So you can practice there, or some other platforms such as HackerRank or CoachF. The key idea here is to develop a method of approach for a particular problem and the thought process involved while implementing the solution. So once you get it right, you'll be ready to tackle some competitions or interviews. For a second scenario, one can start by identifying the exact requirement and the initial period of search here and there. For most of the cases, it will suffice, and you'll find someone who has encountered the same thing and someone else who has the perfect answer for you. But for an involved requirement, one needs to formulate a query so that it can be communicated to a friend or to a forum. Communities like Stack Overflow or individual software forums provide such discussion platform. Finally, if you want, you can implement those in your own way such that it suits your tasks, and also you should probably keep a note of it for future reference. With that said, let me wind up this talk mentioning some effects of co-curricular activities in the course of your journey. So I have been involved with art and music for quite some time now, and personally feel that art enhances your observation, and while you are observing something and doing something, or imagining something and implementing that, it builds up your concentration levels also. Also, music gives a similar kind of experience, and it also enhances and gives you a fresh start to do or walk something uh, that you are already pursuing. So, with that, I thank you everyone for listening, all the organizers for their hard work.
And thank you so much, Sampreet. The talk was really fantastic. Now I feel really sad to even show my next slides. Uh, I would like to ask the participants if they have any queries, they can ask. So first question is, it's a kind of exceptional presentation. The design in particular, if it's not too much to ask, what's the software do you use to design your presentation?
I basically did all of this in Microsoft PowerPoint. Okay, I can. Okay, the screen is not visible, right? Okay, I could have shown the.
Yeah, it's not visible.
Okay, so I'll just share the screen. Yeah, now it's visible probably.
I even don't know these facilities are there in Microsoft Word or Microsoft PowerPoint.
Yeah, Microsoft
Really
PowerPoint
awesome.
is really powerful. This thing, you can do a lot of things here. Okay.
So any more question?
Anything else?
If you do
Sampreet,
not have any question, yeah. Okay.
can you show your slide number 16 and how you managed to do all of that?
Okay, like 15 to 16, the transition. This one. Is it this slide? Hello?
Yes, sir. I too have that doubt.
So yeah, like going from here to here. Is this the doubt?
Yes, sir.
So what I did here is like basically I used the first.
Sir, it's not like that, but sometimes even though we do day-to-day list, but sometimes we can't able to follow all those things now because of some distractions. How you manage those distractions? That's the thing I need to ask, sir.
Okay, yeah. So managing the distractions. Yeah, no. At one point of time, everyone has something or other which distracts them, right? So in my case, whatever I do is like a kind of passion. Like especially whenever I have some distraction, I sit back and get down to code something. So coding is like a passion for me, and I sit down and like as I do those stuff, like hours pass by, and I don't even know. I don't even know how time goes at that point of time. So by the time I get up completing the work, I'm already uh, out of that distraction. Right?
And
Okay,
one
sir.
more new product comes up.
Yeah.
Yeah, Sampreet, this slide, how did you manage to do this, as in rearranging and all of that?
Okay. This one is basically I use this transition called something morph transition. What morph does is it rearranges the things from the previous to the next slide. So it's nothing like I have to do. Like I just have to arrange the elements accordingly. So first I have all these elements here, and then I just arrange it accordingly and systematically. Then I just hit them off. So some of these things might not be available right now to the PowerPoint 2016, and Like, I think this is only in Office 365 subscription, probably. I have to check that. Yeah, someone already pointed it's a feature in 365.
So, any more question, anyone? Okay then, and let us thank again Mr. Sampreet for his wonderful talk. He has made such a brilliant effort to make these slides. I really appreciate it. Again, a lot of thanks to you for coming to this event. Now, I would like to move to our next speaker. Yeah, Mr. Joy Prakash Das. 1 second, let me share my screen. So, I am feeling very shy now to show my slides. Anyway, so Mr. Joy Prakash Das is Dr. Joy Prakash Das is now Post-Doctoral Researcher at SNBNCBS National Center for Basic Science, Kolkata. So he was an Institute Silver Medalist in the BTech program. He received multiple Best Poster Awards, multiple Oral Presentation Awards, 3-minute Thesis Presentation Award, and he was also a former project engineer at Wipro Technologies. He qualified CSIR NET in physical science, mathematical science. He qualified GATE in physics, mathematics, electronics, communication engineering. Like he qualified almost everything. We can't even imagine of qualifying one exam, and he has cleared 2 exams in multiple subjects. It's really brilliant to have him with us. So let me point that he has won Best Institute Best Poster Award sponsored by Springer in the Research Conclave 2017. Won the Best Poster Award in 5th International Conference on Advanced Nanomaterials and Nanotechnology. He won the second Best Poster Award in the poster session at the SARP School on Quantum Optics held at IIT Guwahati. He won Best Oral Presentation Award in National Conference on Hard and Soft Condensed Matter Physics held at Tezpur University. He won the second Best Oral Presentation Award in Physics in the Research Conclave 2019. He won Best 3-minute Thesis Presentation Award in Research Conclave 2019. So, the title of his talk is Presenting Your Research and Underrated Research. I think it will give us a lot of new things to learn from him. Joyda, can we now move to Joyda? Hello, Joyda, can you hear me?
I can hear you. So, can you hear me?
Yes, sir. Yes.
Okay, can you see my slide? Hello, Rajnandan?
Yeah. Your slides are visible. Yes.
Very good evening to all. So, I'd like to start my presentation by sharing a quotation which says that you can have brilliant ideas, but if you can't get them across, your ideas won't get you anywhere. So it's important for us to consciously put some efforts in improving our presentations. And in this regard, I'd like to thank the student chapter of IIT Guwahati SPIE for organizing such an event, and I'm honored to be a part of it. So in this presentation, I'd like to share some points using which we can improve our presentation. So this is how I'll proceed. Firstly, I'll talk about the importance of presentation skills. Then I'll proceed with what are the most common ways of presenting research, that is oral and poster presentations. And finally, I'll summarize and tell you what are the key points that we can take home from this presentation. Okay, now once you cross your grad school and enter into a research program, there is a change in the way you are being evaluated. So till your master's degree program or probably your coursework, the way you are evaluated is the picture on the left. You sit on a room, you are not allowed to take notes, and then you'll get a question paper where you either need to write the answers or just need to tick some answers and so on. But once you get into research, this thing is going to change. And the thing that you have to do for the rest of your life is just keep on presenting your research every now and then. So this is really crucial for us to learn this art of presentation. Okay, and the thing is that there is no direct relation that a person who was very good at writing exams will be equally good at presenting, because there is an extra element called public speaking, and we all need to learn how we can improve on this. But before that, let me try to emphasize the importance of this. Now, if we get down to the most fundamental question of why are we doing research, that is a question which I feel every researcher should ask oneself every now and then. We may be like, some of us are sitting in labs and we are doing experiments all the time. Some of us are doing some mathematical calculations, while others are sitting down in front of computers and writing codes. While there are some other group of researchers which do some survey and try to get some data. But all these activities, what is the purpose behind doing all these activities? That we want to contribute something to the society at large. In other words, we want to help in the progress of human civilization. Now the thing is, none of us can do anything alone. I mean, we may do something which will be some epsilon delta contribution to the broader picture. But if we want the entire thing to be a success, we need to have a lot of discussions among different varieties of people. The theorists need to discuss with the experimentalists and so on. So this leads to a large number of community gathering, as which we call as conferences and so on, so that we can discuss and with the purpose of exchange of some scientific ideas, so that we can optimize among them and finally give the final product, or in form of some product, it can be some knowledge to the humanity, to the people in general. So this is the idea that behind all the conferences. And now in the world, throughout the world, every now and then there are lots of conferences going on which involves lakhs of rupees. So the main purpose is that it's a community gathering where we can exchange all our ideas. Now we get a lot of privilege while we attend these conferences. For example, they give us a free flight fare, a good accommodation and food and so on. They are investing so much on us just for attending the conference. But what is the purpose? What is the return of investment that we are trying to give to them? And that is one thing which we all should ask oneself, that what are we giving them in return? Is it that we are just going to some conference and roam about places and then come back and all the speakers will present, say something, and we'll just sit in front of them and thinking of something else? So the thing is that the best thing that we can do for all this investment is that if we can present our research well, so that the people sitting on the other end of the room can actually get some idea, and that can lead to some collaboration on that, and we can also get some feedback and so on. Then we are actually helping the conference in fulfilling its main motive, that is exchange of scientific ideas. And for this, we all need to strive to be better presenters. So in other words, if we try to present elegantly so that the other persons understand what we are speaking, then we are not just helping ourselves, we are helping the whole scientific community and the whole world at large. Now, among the major ways of presenting research, 3 of the ways are most prominent, and that is when we do some research and get some findings, we either publish them in some journals, or we present them orally in front of a group of people, or we have a one-to-one discussion in front of a poster. So I don't consider myself qualified to talk about the art of publishing in journals, because when you publish in journals, you always have your supervisor. You won't be publishing alone. So he or she is much more experienced to guide you in this. But in this talk, I'll be concentrating mostly on what are the do's and don'ts in oral presentations, and I'll also touch upon the poster presentations in general. So, okay, this brings me to the end of introduction, and now I'll start with the oral presentation. Okay, so there are some key points which we need to keep in mind while making an oral presentation. the first thing is the starting of a presentation, then followed by the slide content making, how we speak, the verbal communication and the body language that we should carry. I mean, this is an online talk, but generally when we are doing it offline, your body language matters a lot. And finally, how do we handle the questions and comments that comes from the audience? Okay, now starting a conference, the first 5 minutes of your talk is really, really important. And it is in this 5 minutes you have to captivate your audience. It is said that you won't get a second chance to make a first impression. And research says that most of the adults are going to stop listening to your talk if they are not convinced in the first 5 minutes that there is something in the talk for them. So within the first 5 minutes, you have to convince all your audience that this talk is going to help them in some way or the other. You have to say why you are talking about this and that and what is the important role this talk is going to play in their lives. And audience are highly receptive in the beginning. So if you don't catch them in the beginning, it's really difficult to catch them at the later part of the talk. And they will just be sitting idle in front of your talk, pretending to hear. So the first 5 minutes is very important for any talk. The next thing is know your audience. So you should be making your presentation by keeping in mind who are going to listen. You have to decide on the technical level at what depth you are going to take your presentation. For example, before making this presentation, I asked Rajnandan, who are the people who is going to be attending my talk? He says that MSc students or like PhD students and so on. So we have to, just like that, for example, if I'm giving a scientific talk in presence of experts of my field, my talk will be different. And if I'm presenting my research in front of school students, then I have to take down the level of the talk so that these kids can appreciate. So it's very important to keep in mind that we need to take into account who are the audience of our talk, who are going to listen to our talk. Because otherwise, if you just say the same things in front of everybody, then it's simply not going to work. Okay. The next thing is avoid casual or negative start. I mean, it's often seen, even among like the elders, that one may be tempted to start in some negative or some casual fashions. I'll give some examples. For example, some may start a presentation by saying that, well, I could not prepare well, but I'll try my best to deliver and so on. And also some people, okay, like if there are some technical things like, am I audible to the backbenchers? I mean, see, you are going in front of a public and the first words that comes to you in front of a big audience is not that, am I audible to the backbenchers? I mean, these things, if you want to check, you can do them in the previous break time when there is no audience or something. But your starting should be a bit captivating. For example, if you have noticed in the initial part, I've started my talk by saying a quotation that, look, this is how important the presentation should be. Now, okay, some may say that some people are yet to come, but we can start. So these are all some kind of casual talks, which we should avoid while presenting. Okay, now instead what we can do is we can start our presentation by saying something interesting. We can say an astonishing fact. For example, if we are doing research on some cure of some disease, then we can say that, do you know this many people die every year because of so and so disease? Then immediately catch the attention of the audience and you get a lot of like interest. Then we can start with some story or perhaps with some jokes. And sometimes we can start with an arousing questions, quotations, some pictures and so on. The idea, as I've said, the first 5 minutes are crucial and you have to captivate your audience during that period. Now, the next thing is title. Now, it's important that you give a simple title which is understandable. You can make it look somewhat interesting, but you cannot like play with the title, like you cannot make it very technical so that people by looking at the title get afraid and so on. And avoid long titles. For example, if I show a title like this, a comparative study of artificial neural networks using reinforcement learning and multidimensional Bayesian classification using Pearson density estimation for identification of GC, Ames spectra, partially methylated alditol excites on the World Wide Web. I mean, it seems the author is interested to tell everything in the title only. He's impatient. He cannot wait for you to go to the abstract and results and conclusions. So you have to avoid very long titles and try to make sure that a title comes within 1 or max 2 lines. Then we have to focus on the initial part of the presentation, that what is the takeaway for audience, because the audience wants to know. Audience is not really interested what and all you have done in your research. They are interested in like knowing how are we going to be benefited by listening to you. For example, if you have noticed, in my first part, I told that why it's important, because like I told that now that you have come into a research thing, for the rest of the lives, your way of evaluation will be just presentations, presentations, and presentations. So that may click you that, okay, this is going to be important. And by listening to this, maybe I learned something new on how to improve my presentations and so on. So we have to give some hooks that what is the audience take-home message from your presentations. Okay, the next important thing is the roadmap. Like we cannot just lay some scattered information of this, that in front of an audience. The audience, we have to go in some structured manner. I mean, this is generally done, but the main thing which we need to keep in mind is that it has to be some key result that we are trying to convey through this presentation. And this structured way, that in this roadmap, what we have to keep in touch with a key idea, and we have to proceed sequentially. We cannot just be random and say this thing, that thing. I mean, I'm talking about formal presentations. In an informal presentations, you can do many things, but in formal presentations, it's better if you follow some roadmap. Now, the next thing which comes to like presenters is that they may get nervous. This is a very common problem among most of the presenters. So the thing is that being nervous is totally fine, but you should not show it. Like, I mean, for that, if you have to take care of that, you have to be scripted. At least for the first 3-4 minutes, you have to be scripted, because once you enter into your presentation, then the nervousness will go. Nervousness generally remains let's say from half an hour from the start of a presentation to your presentation start. So, but the thing is that if because of nervousness, if you do something stupid, let's say something fell down on the stage or something happened because of your nervousness, then that is going to affect your presentation throughout. So at least if you are getting nervous, you need not show it, and to avoid showing it, you have to be scripted. What you will do, it has to be like done many times before, at least the first few minutes, and after that you will be totally fine. Okay, as I've told, writing a script. Now the thing is that being students, like it is often seen that you are not given much time to present your research in conferences and so on. Maximum I've seen that a student is given around 15 minutes. So in 15 minutes, if you are to deliver a speech or a talk including all your results and so on, you have to be totally scripted. Else, like the words may not flow into your mind, and like you may be thinking like, well, this is and my result is all this when all these things will come. So if you want the words to flow incessantly, you better make a script. I mean, but at the same time, do not read the script while presenting. I mean, this is a really weird situation. I've seen that people are actually reading from scripts. This is not done. But the main idea why I'm telling you to write a script is that so that you have written down the words and the words are somewhere in your memory. And you don't need to like think of what I'm going to speak during the presentation. Okay. So now, till now, I have like talked about oral presentation. What is the importance of the starting of an oral presentation, and what are the things we can do at the start of a presentation? Now the next thing is that content making, while we are actually sitting in front of a computer and making the slides for the presentation. Now the first thing is that one key idea. It's not advisable that you may have done works in multiple fields, but if you are talking about, if you're going to a conference, it's advisable that you take one of your work and present it, rather than like telling this. If they're related work, then it's different, but in one presentation, you should not talk about too many unrelated works. So it should be one key idea which you are presenting in your talk. And that has to be organized. For example, in the left image, you can see there is a topic and there are different subparts of the topic, and all this contribute to this topic. So the presentation has to be organized in that way, or there may be some logical flow that this leads to this leads to this leads to this, and finally I conclude with this conclusion. So this has to be maintained in a scientific presentation. Okay, now this is very important, content per slide. And this is a mistake most of the people make, including professors and very experienced people, is that they give too much of information or data in just one slide. Let me tell you, I have never seen any conferences which tells that you can give only this many number of slides. There is never a restriction on the number of slides. There may be restrictions on time, but there is never a restriction on the number of slides. So if at all you have so much of information, the best thing is that you please divide this information into many slides, let's say 2 slides or 3 slides and so on. Because the problem with too much of data in one slide is that if you want the audience to focus on a specific image within that slide, I mean, it's natural for the audience that they cannot concentrate there. Their eyes will go here and there, and you'll somehow miss the audience in this regard. So the thumb rule is that it's better if you just put maybe 2 or 3 equations per slide, or maybe 1 or 2 plots per slide. That's it. Your presentation has to be remain empty. I mean, the presentation cannot be very crowded. Most of the space, as you can see in this slide itself, most of the space is empty. This is required for a formal presentation. Okay. The next thing is that avoid writing paragraphs in your presentation. Like, even if you want to say something, say some connected series of things, still it is not advisable that you write paragraphs in presentation. This is, you're not writing a report, you're presenting something, and audience are not lazy to read all these things. And when you are presenting, I mean, like, nobody is much interested. Firstly, it's not their work, it's your interest, and if you, it's your responsibility to get their interest, and this is not how you get their interest. So please avoid writing paragraphs in presentations. You can just mention the key points and then you can elaborate using words. So, like, try to minimize the number of words in your presentation. Use, and whatever you want to convey verbally. And there should be a balance between your words, equations, and graphs. Now, coming to creative display, as I've told that it's important to catch the attention of the audience, and if you have to like maintain that attention, then it's important that on and off you give some creative things. And Sampreet has already given a lot of like ideas about technologies through which you can make your things creative, because that keeps the audience interested. Otherwise, they may just get away with your presentation. Okay, so being normal is sometimes boring, and it is sometimes good, even in scientific presentations, that you give some animations and caricatures that may explain things better. So I'd like to give a couple of examples from my presentations, which I used to display in my presentations. So for example, consider this. So this is an expression of a Hamiltonian, which says that we have some kinetic energy, some potential energy, some interactions, and so on. So if I displayed this, I mean, audience will have to take the pains of visualizing like what is he doing, what is the system all about. But instead, what I used to show is this. Now here I used to show this image and tell that these cartoon athletes running here and there, these are the electrons moving in both the directions in a 1D system. The barriers that they are jumping, these are representing some potential barriers. I mean, these are basically impurities which we have modeled as potential barriers. And that watery surface in the middle, that is actually a potential well. So if I represent my Hamiltonian like this, it's much easier for the people to appreciate, okay, this guy is going to work on such systems and probably is going to do something about it. This is what we call as a quantum steeplechase. And steeplechase is an Olympic event, I mean, what you can see, that game is actually called steeplechase. So this is one of the way that you can think of making your content creative. I'll tell you one more example. And this is again one slide from my presentation. I mean, I never lose a chance to popularize my work, and this is one effort to do that. So now we have developed a technique called non-chiral bosonization now in the recent years. So I want to show to the people that why this is important to you. for that, I say that whatever is in the conventional bossonization, I mean, this picture, don't worry about the equation. Let's say this green box is something, the conventional bossonization. And it works fine for homogeneous system where there is no impurities or no barriers. And this bossonization scheme can work on these systems to get you the Green's function. This bossonization can also work for other kind of systems where you have an infinite barrier, where the reflection coefficient is 1. And this can also give you the Green's function. But if you have something like an intermediate potential where there is simultaneously reflection as well as transmission, then this conventional bossonization cannot give you the Green's function. And this is where we come into picture by a new method called non-chiral bossonization, which looks like this big green box on the left. And if you use this scheme, then this can work on even these kind of systems to give you the Green's function. Now, if I say, if I deliver this message in this way, then everybody can understand that, okay, the conventional methods can do this and this, but this new way of doing bossonization can do this, this, as well as this. So if I write all these things in form of bullet points or some mathematical equations, then it will be really painful for the audience to appreciate, because I have to tell all those things in 1 or 2 minutes, because I just have 15 minutes in my presentation. So my advice is that you should always think of something creative so that the audience is interested as well as your message is conveyed. As I've already told, that the purpose of conferences is to exchange the scientific ideas, and you have to put some efforts in making some creative work so that the purpose of the conference is fulfilled. Okay, the next thing is time limit. Now, one of the important things is that I've seen many of the speakers that they generally run out of time. I mean, somewhere in the mid, they will say, okay, perhaps I should stop now. Or they will say, can the organizers give me some 5-10 minutes? I mean, what the organizers will say, you are an invited speaker. They cannot say, cannot say anything. They have to give you time. But the thing is that the conference gets delayed and so on. So please try to make sure that you rehearse and do not speculate that, okay, I can manage all these things within the 20 minutes or 30 minutes. So it's better to rehearse and make sure that this is true. And also, while rehearsing, you have to expect interruptions in between. If you get some nasty fellows in the conferences, they will just make you stuck at one point because you cannot move. They will keep on asking questions after questions. This is something which is unavoidable sometimes. But the best thing is that, like, if you're given a time of, let's say, 20 minutes, try to make sure you finish it by 17 to 18 minutes so that you can take care of the interruptions in between. And finally, you should decide on the technical details. For example, in my, let's say, defense seminar, I can speak for, let's say, 1 hour. Let's say in my synopsis, I may speak for half an hour. Let's say in some conferences when I'm taking part, I'll be given just 15 minutes. And a 3-minute thesis presentation, I just have 3 minutes to talk about my thesis. So what is the amount of technical details that I'm going to spend on all of this? In each of these cases, I have to say one thing, that is my thesis title, that is non-chiral bossonization. But I have to adjust my technical details without missing the bigger picture. It's not that I will start something and end in between. No, it has to be smooth. But the level of technical details you have to adjust based on the amount of time that you have. Okay. Now, one important feature which almost everybody ignores is the use of fonts. But this is important. As per the visual psychophysicists, they have done research on what font suits to the eyes in what context and so on. Firstly, the basic features is that uniformity of fonts. Like, it should not be that one slide starts with Times New Roman, the next slide starts with Arial, the third will start with Calibri, and no. You have to maintain the uniformity in the fonts. And the other thing is that use of serif versus the use of sans serif. Now, serif fonts are the ones, as you can see on the left. Okay, if I have this pointer option. Yes. So this is an example of a serif font. You can see this dash at the ends of the S. So these type of fonts are called serif. The examples are Times New Roman and Courier. Now the thing is that these serif category of fonts is suited to in piece of paper. When you read some books, you will find that all your textbooks are printed in serif fonts, whether it's Time New Roman or Courier or whatever. But when it comes to presentation, the research says that you should use sans serif. Sans means without serif. That means without this dash. So you can see in the S on the right hand side, there is no dash, and this kind of fonts are easy for the eyes to read in the form of a presentation. So while making presentations, please use fonts like Arial, Calibri, Comic Sans, where you have non-serif. For example, all these fonts you can see, these are built in Calibri. So this is one thing we need to keep in mind. The other thing is that the font size, it's like we have to know that it's not that we can make something as big as possible. I mean, if it's a thank you slide, then it's a different thing. We can make a big thank you. But other than that, it's preferable that our fonts remain between 18 to 36. An exception is the references. We sometimes write references to journals at the bottom of the screen, and that we can use 14. Now, the next thing is avoid using capital letters while writing sentences, because this is somewhat distracting to the eyes. I mean, people generally write some sentence in capital that they want to focus, but this is actually not advisable for formal scientific presentations, because these capital letters are like the visual equivalent of shouting at the audience. So avoid capital letters as much as possible. Some titles and all are fine. Titles and thank you slides are fine, but for the rest of the presentation, avoid. Now coming to color contrast. So Sampreet has already talked about this in much detail, but still I'll just give a brief overview. When you are giving talks in conferences, try to prefer a simple background, preferably white, and black letters on a white background, or vice versa. So research says that if you are speaking in front of a small audience or in a classroom kind of structure, then you better use white background and black letters. But if you are into some big symposium, let's say you have more than 200 200 number of viewers, then you can use the other way around, that is white letters on a black background. And avoid some disturbing combinations. For example, this is the most terrible combination, green letters on a red background, and you can actually see people playing around with a lot of colors in the presentation, even in conferences. Maybe they are fans of Sanjay Leela Bhansali or so, I don't know, but they just play with colors. This is not what is advisable. I mean, for example, in my presentation, I've tried to show that just used black, blue, and a white background. That's it. So, I mean, this is supposed to be informal talk, but I cannot talk informally because I'm talking about formal presentations while being in an informal talk. So, avoid using too much colors. I mean, you can always play around with colors when you are giving some kind of casual talk or something, but in scientific presentations, please avoid too much of color combinations, and also avoid fancy backgrounds like this. I mean, in fact, if you present in front of in your progress seminars and where you have a panel and all, you may be getting some negative remarks for that. Okay, now keeping margins. I mean, this is not as simple as it looks, because why? Because of this thing called projector alignment. I have seen when you go for giving a presentation to some colleges or to some universities, then there may be a problem that the projector is not exactly aligned with the white screen that is on the wall. Sometimes it happens that the bottom thing gets cut. In fact, it happened once that, like, we were doing in an IIT Guwahati auditorium, we are doing some kind of a musical event, and there was a PPT to be played in the background while the event was going on. So when I tested the presentation, I made the presentation, and it was found that the top part was not visible. And I was really worried about that. And the technical person told me that, why don't you change the slides and just bring all the titles, all the headings down? But I told that's not possible. It's a 40 slides or something. So for that purpose, it's always advisable that you keep spaces on all the sides. Don't take your presentation till the bottom, because sometimes you have to depend on projectors which are not perfectly aligned, and you may miss some of the corners of your presentation. Okay. Now, like, these were the main things of content making, but I'd like to share some more points. Firstly, there should be heading in each slide. If you have noticed, like, each of my slide has a heading, so that so that the viewers know that, okay, in this slide he's going to talk about this, and then I'll slowly elaborate on that heading. That's a good convention. Then unveil your list one by one. If you are like presenting something where you are trying to make up some points one by one, it's always good advisable to use the feature of like a one at a time animation feature, because suppose if I just show you everything and then I talk about heading in each slide, then naturally you may not be focusing on that and you may be reading what is on the next part of the slide, on the bottom of the slide. You may be reading here and there. So it's always good to unveil your list one by one. Then the next thing is like, I don't know, maybe like some people may be interested to show that like, okay, I have done this much of work, but that's actually because nobody much cares about how much you have done. So even so, people, what they do is that they show a lot of things in the slide and then say that I will skip all this and I'll just present you this. That doesn't mean anything. So it's better whatever you won't be explaining in the presentation, please avoid putting them. That keeps your presentation simple and sweet. And this is the key rule of content making. You have to start broad. You have to say something very broad in the beginning so that so that you can capture more and more audience. For example, when I talk about bosanization, if I directly start with bosanization, maybe 2 or 3 people in the crowd will be interested who actually works on bosanization. So I have to start from something very basic. I used to start from, let's say, nanotechnology. Then I say 1 dimensions, why 1D materials are important, then experiments in theory, then in theory what we can do, and then in what we can do in 1D systems in theory, bosanization is one of them. So I start broad and then I narrow down and get specific to this. And finally, again, I end broad. So that should be the strategy of a presentation. If you directly start at a very narrow level of a very specific level, then in the initial 5 minutes, which are the most important part of your presentation, you're going to lose a lot of audience. Okay, now the final thing about this is the audience attention curve. I mean, everybody of us would realize that, many of you must have seen this for the first time, but even by looking at this, you would know that, okay, this makes sense because the attention of an audience initially is very high. Then as you proceed with the presentation, maybe now I'm in the middle of presentation, maybe I'm somewhere here, but I'm trying my best so that to capture you. Now, the initial part of the presentation, the audience are really motivated and they want to know and all. And then finally goes on. And when you say that, okay, now let me conclude, then again they become happy. Okay, it's going to end. And again, the attention of the audience increases. Now, what we have to do is this. If we want to keep the audience in our presentation, so we have, instead of following the diagram on the top, we have to follow this. Let me explain what it means. Like, this is the technical depth in the downward axis, and this is the time on the rightward axis. So it's not that we slowly go into depth and then we keep on showing one result after another and go into technical level and then finally end the presentation. Then we are going to lose many of our viewers. What we have to do is we go into some details, then again start from go to the basic level again. For example, this are the results. So now we can say some kind of a mini summary kind of stuff that, okay, we are actually presently working on these kind of systems. We are looking at this feature, and till now we have seen this. Now let us go to the next section and see what are the things there. So if you follow this rule, then there is more chance, I don't say 100% chance, but there is more chance that you will involve the audience, because what will happen in these dipped regions is that those audience which might have felt that, okay, now I'm getting away from this talk, then you can take them along with, because when you say that summary lines that in the last 10 minutes I have talked about this and these are key results in words in a very simple way, then they will again be back to the presentation and they will be motivated to proceed with the next detail. So this is the rule, and these are all research findings. Okay, now I've completed the initial part of the presentation and the content making. Now the third most important part is the verbal communication and your body language. Now, when it comes to verbal communication, why I've put English in the first place, this is because when you are fluent in a language, I mean, we are all at some learning stage when we are all trying to improve, but we have to put some conscious efforts in improving that. And the fluency in the language, whether it is in English or any other language that you are presenting, but when you are very much fluent in that language, it boosts your confidence. I mean, keeping all other factors like content making, initial part, your research work, everything constant, your confidence will be more when you are much more fluent with the language. And some of the wrong things which ideas, I mean, I have faced people may have is that watching some English movies or attending some foreign conference is not really going to help with your English, because that you may at the end of the day have some foreign kind of accent while talking. But if you really want to uh, improve your English, it's better to buy a 200 rupees book like this. This is and study it for 1 month, and I believe me, this is going to help you for the rest of your lives, not only in presentations but also while writing papers. Okay, now body gestures. Now you have to show your voice or your body language should show that you yourself are interested. Firstly, if the audience think that, okay, this guy and maybe his guide has pressurized you to come here and give this presentation, it should not look like this. You yourself, even if you're not interested, at least your body language should show the people that, okay, you are really interested in what you're speaking. And that's important. And we have to avoid some kind of negative body language. For example, somebody asks you a question, you can say with open hands, but instead of that, if you just point fingers saying that, look, this is how it is, you should have you read this, and so on. These are negative things. And other thing is, like, as you can see, that person on the right, like somebody asks you a question and you are standing in front of you with folded hands, that like somewhat psychologically it signifies that, okay, like you are, that is actually a defensive kind of thing, that you are not, I mean, in a very good if they ask you a question and you are standing folded hands, then it's like little bit like you are not much caring and you are not like much liking that he's asking a question, and so on. These are, you can also always do some research yourself on these posters. Okay, the other interesting thing is facing the crowd. I have seen people, while this is an extreme image, don't go by this image, but many of the people, especially the ones who are new to this presenting stuff, young doctoral students and so on, all they do is like, initial they will say, good morning, today I'll be talking on this topic, and then they will slowly turn their body and the head, and then they will look at the screen, and the next time they will again face the crowd is when they say, with this I'd like to conclude. And all the time they are just looking at the presentation. This is not how it should be, and that's why it connects to why I say that you should not write much in your presentation. You should just write the words. As you can see, I've been just writing some key words, and then I'm using my language to express them to you. So the best thing is that, so you can just turn them a while and see what that word is, and then you can face the audience and speak to them. So when you actually speak face to face, the audience get connected. Otherwise, like you are looking into some slide and the audience is looking into some slide, that doesn't make the connection good. Okay. As I already said, do not read your slides. Your audience knows how to read and write. You are presenting in front of some scientist and so on. Okay. And mention the keyword and elaborate verbally. So as I've told, like instead of just like what I'm doing here, I'm just writing the minimum what I can write, and then I'm trying to elaborate on this instead of like writing the whole thing and then just read. Because if at all you need the audience to read something, let's say some very important, like you want to paraphrase what others have said, in that case, it's better that you just show them on a slide and give the audience half a minute to read it. That's no harm in that. But it's not advisable that you just keep on reading your slides. Okay. And finally, when you make your presentation, it's always a good idea to give some mock presentation in front of your friends, because that's not only going to take off your nervousness, but they can always give you some feedbacks. And also you can make some, if you don't have friends, you're an introvert person, then you can take videos of yourself and then look at it, how it is actually sounding. Now, let's come to handling questions. This is an important part of a presentation, because this is the part of the presentation which is feared by most of the presenters. Because whatever we are going to present, that we anyway will practice, and whatever research we are doing, nobody knows that research up to that level as we know. So, but the thing is that what we really fear is what kind of questions the panel will ask. Will some professor ask me some very difficult question? What if like I don't know an answer to some basic question? Will he laugh at me, and so on and so forth? So this is something we need to consciously think of and and decide what we should do in all such circumstances. So what I have done is that I have made two axes. whether like x-axis represents whether I know or don't know, and the y-axis represents whether that is related, whether that question is related to my topic or it is not. So suppose let's come to the first quadrant. Now, if there is a question from the audience that we know, so this is the best situation, like they are asking you a relevant question and we know. So all we need to do is that politely you need to answer it slowly, and like you can thank the like whoever has asked that question, you can always thank him saying that thank you for the question. The answer to this is so and so, and etc. etc. Okay. The next thing is that you get a question which is not related to your research, but still you know you have an answer for that. I mean, that is even better. But you can politely say that this is not exactly what I'm working on, or this is beyond the scope, but I have an answer for that. This is so and so and so forth. Okay. The next thing is that somebody asks you a very non-related question. Maybe he's trying to relate your research with his research, and like he asks you some very like tricky question on like and which is beyond the scope of this. And for this you have the main two things in these questions is that you have to be polite, and the second thing is that you should always try to go on with the presentation. You should avoid dumb silence for more than a few seconds, because that somewhat becomes embarrassing, because you may not always get an audience which is like say, okay, we can discuss it later, can you go on with the presentation. Sometimes you have to grab that opportunity yourself. So you can say that, well, I'm not very well versed in this, and this is not directly related to my research, but I'll try to get back to you on this and something. And the most fearful part is that when you are being asked a question which is directly related to your research and you don't know an answer, this is something you should be well prepared in such situations, because however much you try with your presentation, however much you like study the basic literature and so on, there may be something which you might have overlooked. So in such situations, you have to say a few words so that you can go on with the presentations, and you have to figure out what those words are. For example, the first thing in this regard is that you should not bluff. I mean, there is just maybe even if there is just 1% chance that you will be caught bluffing, but still you should not be bluffing in this regard. You can say that, this somehow escaped my attention, and thank you for asking this question. I'll definitely look into it, and thank you for your suggestion. Or you can say that, this is a very crucial question for my research, but I somehow missed it while getting into details of the research, but I'll definitely go back and search the literature, and I will definitely let you know later. And something of that sort you have to say. I mean, if you just stay there and like thinking what to say, what not to say, and totally silent, then that may not be considered very good, because you don't have an answer. You have to say, and if required, you have to apologize that, well, I should have known this, but I don't have an answer to this. But you have to speak something. Either you say you don't know, you know, I'll try to know, etc. But don't keep silent for like too long. Now this brings me to the end of the oral presentations. So I start with how important presentation skills is, then what are the do's and don'ts of an oral presentation, and now I'll briefly take you to poster presentations. And most of the things remain same, but there are some additional things, because firstly, poster presentation is different from oral presentation in the sense that there it was a public speaking, but here it is just a one-to-one conversation between two persons in front of a poster, and there will be like many posters in and around. This is more like informal as compared to the poster presentations. So you should always start with some short greetings when somebody come. I mean, instead of directly jumping, say, okay, this is my Hamiltonian, this is how I solve this Hamiltonian, and so on. The next thing is like brief introduction in words. I mean, I'm not asking you to read the introduction that you have written on the poster, but don't directly jump into technical details. Let's say, for example, I used to say that we are a group working in quantum many-body physics, concentrating mainly on systems, mainly on 1D electronic systems, and so on. Firstly, tell it 1 or 2 lines in words so that whoever is coming to visit your poster is at ease, instead of directly saying that, okay, this is what I do, this is what I solve, and so on. Now, this is just like too much content in one slide. Similarly, in case of a poster, it said that let your poster breathe. Around 40% of your poster should be empty. Like, you need not dump everything into one poster, because your poster is not a standalone thing. You and your poster makes the whole thing complete. So some things have to be written to poster, and some things you'll have to say verbally, and that is how the whole thing gets complete. So please don't dump everything into the poster, and so that like the reader gets scared by looking into poster. So keep a lot of empty spaces in the poster. That is the idea. Now the next thing is like eye contact. As I've said, like instead of just looking at the poster, you have to maintain some amount of eye contact to your listener, and instead of looking here and there, or like whoever else is coming, let's say you are presenting your poster to someone and some friends come, you say, hi, how are you? That's these kind of things you should avoid. Although it's a very casual presentation, it's not like that you are talking in front of an audience in a seminar hall, but still in poster presentation, this is important. Supplementary material. As I've told in the third point, that let your poster breathe. That means you should keep minimum content in your poster. So that means some readers may be interested in more details, and like which he will not find in the poster. So it's always good to keep some printouts of some of the, let's say, derivations or some key results which you are not mentioning in the poster, so that you can hand over to him. Because some people may be really interested in your work and they want to know the details. So it'll be very handy if you keep some printouts of the technical details. And title should be short. I've already told in case of oral presentation. Then sectioning of the poster. It should be like, as I've told in the oral presentation as well, it should come under certain headings, and there should be a sequential flow among all the headings. And the poster, like whether you make it a 2-column poster or 3-column poster, it should have the sections like which should be very clear what each section is all about. And the reader can choose the section they are really interested in among your poster. As I've already told, don't put everything into the poster, keep empty spaces, and if required, keep some supplementary materials. Scripting and storytelling is also required for a poster, provided if you are new to this research and you sometimes go out of your words, because you have to explain many people, and like at least for the first few times when you present a poster, a scripting will be definitely a good idea, I suggest. And in your poster, you should prefer more images and graphs and flowcharts over words, and prefer points to paragraphs. I mean, I think it's advisable that other than your abstract and your introduction, I mean, there should be no paragraphs in your poster at all. If you are like giving some scientific poster, or I mean, because nobody's interested in reading paragraphs or stories in your poster. All they're interested in some key points and some plots and graphs and so on. Finally, the background should be very simple. The white is the best for that. And font, now the font is reversed, because as I've told, the serif kind of font are good for writing books and so on. So poster is also something which is printed on the paper. So here you should, for the body of the poster, you should prefer any kind of serif fonts like Times New Roman, but the titles you can continue with the sans serif. Okay, you have another point is that you have to make sure that the poster is visible from some 5 or 6 feet. At least the titles are visible. So for that, you have to make sure that whatever you're printing, you have to make sure that you are looking into the zoom level, because often what it is found that when people are making the poster in your computer screen, you actually zoom and make the poster, and finally when you give a printout, you see that they are either very small or very very large. So for that purpose, you have to make sure that you do 100% in the zoom section and see how it actually looks, and you can actually go far away from the laptop and see how much, because nobody is going to like see your poster from, let's say, 25 centimeters so on. They may be standing, let's say, 2 feet away from the poster while you two are discussing. For that, the font size and all those zoom levels are important. And the main motive of presentation, as I already told, is like building, sharing some scientific ideas, and also to build context, because in poster you get a one-to-one, you get a chance to do a one-to-one conversation with persons, and there is a good chance that you can build up collaborators, because you two can talk very freely, and everything is on the poster, all the headings and all the research things that you're doing. So that you can always take this an opportunity to build some context with other eminent persons in the field. That is going to be really helpful. So this is always a good idea that you put a QR code which will lead to your URL, so that they can easily contact you, instead of like writing some website name or so on, you can use the technology for that and try to see if you can build collaboration, because that's going to help you in the long run. So finally, after winding up with oral and poster presentation, I'd just like to summarize. So in this talk, I've told why a good presentation is important and what are some of the things. I mean, I'd like to remind you that whatever I've told is by no means an presentation better, because I have seen like many people, what they do is that if tomorrow is your presentation, till today midnight they will be in labs taking data and getting more data or getting more output from the code so that they can dump more and more results to the oral presentations. But that is not something which we should do. Like, it should be like we should put a few hours at least, not just few hours, a few days for thinking like what would the audience like, how will I improve my presentation, is it that I am talking and I'm not able to convey the message, so how is it that I'm going to convey my scientific progress to others and so on. So some of the takeaway points for this good presentation is that prepare consciously, then make some creative content, because as you have seen in the audience graph, like the audience attention span is not always constant. It goes really down, and you have to make some creative content to capture that attention of the audience. Then do not speculate. Don't think that, okay, I'm liking this, so others will also like this and so on. Whatever you do based on the research, some people are actually doing research exclusively on these kind of things. For example, which fonts are good for the eyes in the poster or in the presentation and so on. Rely on their data. And finally, be audience oriented. You should know what the audience wants. I mean, if the audience is a bunch of chemists and you are presenting some physics, you have to be in a very basic level so that they can appreciate. You cannot show all the technical details and thing and just brag that, okay, I have done some very great stuff. So be audience oriented in that way. So I hope I have given you some idea of how we can improve our presentations, and I hope I've convinced that up to certain extent that why focusing on a presentation is really important for not just for you and me, but for the scientific community at large. So with this, I'd like to conclude. Thank you.
Thank you so much, Joyda. It was really a nice session. Can we have questions, please? Joyda, we have a question.
Yeah, sure.
Sir, if suppose a conference is containing more than 700 people, then how to face those audience? Means where and how to focus all?
Yeah, first thing which I'd like to tell you is, okay, let me, are you still able to see my screen?
Yes, we can see your screen.
I have to see the chat. Let me try to see okay. If suppose a conference containing more than 700 people, then how to face those audience, means how to focus at all. Firstly, that you are not going to start a presentation with 700 people. I mean, getting 700 audience is not a joke. You have to start with a few people, and that's how it actually starts. Like when you are presenting in your college or among your friends or whatever, so you have to make sure that you are doing well there, and like slowly you have to get to more audience. And finally, if you see that after you make some 30-40 presentations, it's just not going to matter to you how many people are really watching you. It's just going to, the graph is not like your nervousness is proportional to the number of people. After a certain level, it's going to saturate. So I think whatever I've told in terms of like content making and scripting and all, so if you have actually like studied them well and just prepared the whole thing well, I mean scripted, that at least the first few minutes are scripted, then I don't think it's a difference. The number doesn't matter you much. So that's what I like to say. And like you need not focus, even if let's say you are, suppose you are into a crowd of 700, then like you need not focus on it. It's just a general kind of stuff. You need not focus on like how many people, who are the people sitting. It's just that you're like, it's kind of impersonal. You're speaking in front of a great crowd. And firstly, let me tell you, for getting 700, it's better you shift to some singing or dancing profession. It's for scientific talks, you hardly get 30-40 people. Okay, I can take the next question. That was a joke, by the way. So yeah,
from
Rajna,
Kanika,
yeah.
some tips to improve the speaking skills for presentation.
Which one? Some tips to improve the speaking skills for presentation. See, there are twofold way to do this. Like, firstly, if you're, let's say, okay, let's talk about speaking in English. Like, firstly, one is the grammar point of view that you cannot just learn by like keeping on speaking, because if you speak in wrong English, I'm not saying that and everybody does somewhat mistakes and so on, but if we want to get the grammar right, we have to put some efforts in reading some kind of grammar books and so on. That is the language part of it. But the next part is like expressing yourself. That part you have to like do. So, for example, what you are doing, for example, Rajnandan, I personally believe that these kind of activities really help you. Let's say you are organizing an event. Suppose you are organizing a SPIE event. For that, you have to go to many schools to do publicity. And you cannot directly go to a class. You have to talk to the principals and the teachers and so on. So when you do such kind of activities, especially like while I was a BTech student, I can see that like people do various sorts of activities, some cultural fest and all that actually helps you improve your speaking skills a lot, because just by attending classes and watching some cinemas and all, that's not going to help you. When you actually go out to the field, I mean, this maybe your main intention is to doing publicity or getting some sponsors, but the thing is that in the process you talk to some really big people, some chairman of some company, principal of some college, and so on. While you keep on speaking with all those people, slowly your nervousness will go, and I believe like your speaking skills will improve. So you should do some kind of extracurricular activities like that, which is going to help. Which is the next question I can take?
Yeah. So you can ask the question directly. You can turn on microphone also.
Yes. Okay, I have
two speakers.
Hello, Joyda. It is a nice talk. Thank you, by the way. And I have a question. While presenting, I mean, we face a lot of problem while transitioning from one slide to another. So, what do you think? I mean, which factors do you need to keep in mind so that it will help to make it a synchronized manner? I mean, you got the question, right? I mean, how?
I got the question.
Yes.
Yeah. See, like I personally don't consider like in this specifically in this. I mean, this is something which I've thought of while making present. I used to think of this. I personally feel that there is no dearth of words. Okay, there is like you have enough words that you can connect any two things. Okay, so I mean, suppose you may find some like people, what they do is they want to sell something to you. Okay, then what they do is that when they go to you, they approach you, they directly doesn't, a good salesman will not directly say that I have this product, this is going to do this and this, will you buy it? No, they will start with a very common conversation, and then they will take a turn and slowly, very smoothly they will go to this. So what I believe is that in any 2 pages of your presentation, however disconnected they are, I mean, firstly you should make your conscious efforts to make them connected, but if at all they are disconnected, you can always add some words. That's why you are there. You can always have some words that can connect those 2 slides. I mean, don't never do things like this is my result in this plot shows this versus this, and this is the peak and so on. Next, you suddenly jump to something else. So in between you have to, and that will come only when you script. I mean, that line you have to think of. I mean, while explaining the graphs and so on, that you don't need much of scripting. You can directly say whatever comes in front of you. But the transitioning part, it's better if you prepare beforehand that how do you connect to this. For example, let's say two different problems, but see, somewhere they will, however high it may be, somewhere they will converge. So you can say that, like, with this technique I have done this and this, then you can, but the next page is something very different. So you can say something like, so this is an efficient technique in condensed matter physics, and there is no dearth of other techniques in condensed matter physics which does many other wonderful things. One such other thing is this, and then you can come to this. So using some one or two sentences you can connect, but depends how far you have to go. Maybe sometimes you have to cross physics and go to some other subjects like mathematics, but even that is fine. But using words, you have to maintain the flow of transition. I hope that's best actually I can say as of now. Using words only you have to, and you can have to go anywhere to make that transition. And you have to believe positively that there has to be some words that is going to connect one slide to the next, however different those two slides are. I hope that answers the question.
Okay, thank you.
Okay, and let me read if some question is. Not a question, something to add. The rehearse timing feature in PowerPoint Online is a very useful feature in this regard. They do give useful insights like to Maya. Thank you for this. Actually, this is going to benefit all of you. That rehearse timing feature, I missed it, but thank you for pointing that out. The person who mentioned this was Jesse Pulikotil Francis. Okay, thank you. Okay, I hope there is. This is. Is it possible to share the recorded version of this? Okay, I mean, anyway, we'll get it in YouTube. I agree with, yes, unlike most webinars, okay. Synchronization requires better understanding of the presentation topic. So ask yourself why you are going to present the two slides. Okay, so is there any other question? Hello?
Any question to other speakers as well?
And Vamsi, thank you.
Rajnandan?
Yes, sir.
No, actually, yeah. Basically, they asked me about a website. Actually, I am giving a link to the website where you will get the list of most of the conferences happening around the world. Actually, I have just given the link there. Actually.
Thank you, Indu. So, if we do not have any question, let us move to our next part, the vote of thanks section. I would like to invite Bora to end this.
Thank you, Rajnandan. Good evening, respected teachers, our most valued invited speakers, participants. It's my privilege to have been asked to propose a vote of thanks for today's event. I, Sweetie Bora, on behalf of SPIE Student Chapter, IIT Guwahati, and the organizing team, I extend a very heartfelt vote of thanks to all the speakers for gracing your important work and sharing with us your findings and opinion today. We must mention our deep sense of appreciation for Dr. Indu Kalp Dihingia for sharing his journey towards Best Thesis Award in PhD from IIT Guwahati. Further, we are grateful to Mr. Sampreet Kalita for giving an excellent coverage for using technological tools for research intensification. And we also like to acknowledge our gratitude to Dr. Joy Prakash Das for explaining how to mix and match creativity in research. We are all inspired by your great words. Further, we would like to thank Professor Supradeep Ghosh, HOD Physics, for his support and encouragement. We will remain grateful to Faculty Advisor of SPIE Student Chapter, Professor Tarak Nath De. His constant guidance and motivation has helped us in organizing various events. We would like to thank all. I would like to thank all SPIE members and organizing committee members, especially Rajnandan, Akanshu, Parth, Sampreet, and Raghvendra Posti from IIT Ropar for their involvement and willingness to take on the completion of tasks beyond their comfort zone and making the event a success. Lastly, I would like to thank participants for their active participation. I hope this session will be helpful on your way to find fantastic thesis and research. We thank you for being with us this evening. It has been a great pleasure. Thank you very much. Stay safe, stay healthy.
Thank you, Shruti. So I now move to the next part, the announcement part. We actually organized this event called Design Brain Map and Win Rewards Award. So there were lots of entries, and we had very hard time to find the top 5 position. So the first position was given to Subhranshu Shekhar Giri from NIT Agartala. He made this poster. He actually made 2 entries. The HD quality pictures will be uploaded to the Facebook. So this is another person he submitted. The second prize goes to S. Priyadarsini from Sri Ramakrishna Maths Vivekananda Centenary Girls Higher Secondary School, Chennai. The third prize goes to S. Santoshini, the third year BSc Physics, Chevalier T. Thomas Elizabeth College for Women, Chennai, Tamil Nadu. Fourth prize goes to Tasneem Sultana, 9th semester Integrated MSc Physics, Dibrugarh University. And fifth prize goes to Avichandan Das, MSc 4th semester, Dibrugarh University. And we also give some consolation prize to some other participants. Parthapratim Das from BTech MIT University, UP Noida. Adrija Das, Class 11, Assam Valley School. Vidyanandini Kakati, Class 9, Sankadev Shisu Niketan. Akash Ratan, he actually gave 2 entries. Class 12, APS, LBS Mark Lucknow. Upasna Pathak, MSc 4th semester, Dibrugarh University. And this one is basically off the theme, but to appreciate his effort, we would like to give a consolation prize to Lokesh Mehra, Class 10, Maharishi Vidya Mandir, Bilona. He actually submitted 2 brain maps on brain itself. So let us congratulate the winners and the consolation prize winners again for this Design Brain Map and Win Rewards Award competition. The next competition was Let's Write in 3D. So the top 5 positions are: first one goes to Prantik Nath, Class 9, Royal National Public School. Second one goes to Nilotpal Chaudhary Das, BTech NIT Silchar. He submitted 3 entries. The first one is this one. Second one is on partially reflecting surface, and third one is on glass. The third prize goes to Gopika MS, Research Scholar, Department of Physics, Mahatma Gandhi College, Tiruvananthapuram, Kerala. And fourth prize goes to Akash Ratan, Class 12, APS LVS Mark Lucknow. And fifth prize goes to Adrija Das, Class 11, Assam Valley School. Again, we will be giving some consolation prizes as well to Vidyanandini Kakati, Class 9, Sankadev Shisu Vidya Niketan. Upasna Pathak, MSc 4th semester at Dibrugarh University. He submitted 2 entries actually. And this one is to VC Saha, Class 9, Pragjyotis Senior Secondary School. Tasmeen Sultana Majumdar, Class 12, Cotton University. He actually made this off theme. Again, let us congratulate the winners and the consolation prize holders. Thank you. And this is the feedback link. You will get this feedback link in the YouTube video at the description. We will update it within 30 minutes after this session. And you can give your feedback and receive the e-certificate in your email. And if you have any query, you can write it to us via mail. You can also find us on Facebook on this page. This will be the certificate design basically. So please, the name and institute name will be case sensitive, so write it accordingly. And in our next event, for the school and UG students, Professor H.C. Verma will be there in the event Fantastic Projects and How to Find Them. And for the Masters and PhD scholars, Dr. Biswajit Pathak will be there in the event Optics is not only about optics anymore. So kindly join us. So again, let us thank the speakers, Indu Kalp Dihingia, Samprit Kalita, and Prakash Das for their wonderful effort to make this event a success. And again, the participants. Thank you all.